We are going to discuss the moment of a couple in this class. And by definition, the moment of a couple is defined as the product of one of the forces and the perpendicular distance between the lines of action of the two forces. Understanding what couple is going to help in our adequate comprehension of what the moment of a couple is all about. So, by definition, a couple, just as the name implies, it's just talked about two. Okay, when we talk about couple, it talks about two. I'm sure this is not the first time you're hearing the word couple. Okay, if a man and a woman comes together in marriage, we call them couple. Is that okay? Because one entity is coming together with another entity to form one. Do you understand? So in physics, if we talk about couple is simply a pair of equal parallel forces that are acting or that are opposite in direction. Okay, and I want you to know that the only effect of a couple is to produce or to prevent the turning of a body. This is a likely exam question, so you have to take note of that. So diagrammatically, we can say that if we have this line of action and then a force acting in this direction, okay, because this is at a right angle, okay, and another force acting in the opposite direction, F, because if we consider the distance from here to here, we can call this X. Okay, so realize that these two forces are acting in the opposite direction. This is acting upwards while this is acting downwards, and just like we said, we pointed out that the major focus or the major reason why we need a couple is to prevent or to produce the turning of a body. Is that okay? So this is the pictorial diagrammatical representation of what we just talked about. So mathematically, this is diagrammatically. While mathematically, the moment of a couple is equal to product of force and the distance. Okay, now let us consider an example to illustrate what we just discussed. Two forces of magnitude 25 Newton each act on opposite directions at opposite ends of a circular ring. If the diameter of the ring is 65 centimeters, calculate the magnitude of the couple acting on the ring. We can bring up a pictorial representation of what we are talking about. Remember, we talked about a ring. Okay, so let's call this the circular ring. Okay, and we said that the ring has a diameter. The diameter is a straight line that cuts a circle into two equal halves. So the diameter of this ring is 65 centimeters. Okay, it could be this way, it could be this way. That's still the same thing. Okay, so this is the diameter of the ring. We have to calculate the magnitude of the couple. Remember, we said that a couple is actually two parallel and opposite forces that are equal. Do you understand? There are two equal parallel forces and they are acting in opposite directions. So we can say this is acting in this direction and a force is acting in this other direction. Okay, or we can say that one force is acting in this direction while the other is acting in this direction. So whichever direction you want to take, you're free. Is that okay? Now, and we said that the force is actually 25 Newton. So 25 Newton acting here, 25 Newton acting here. If you are considering this, and this, okay? But if you are considering this, and this point, then 25 Newton will be here and 25 Newton will be here as well. So what is our focus? Our major focus is to calculate the moment of the couple. And we said the moment of a couple is the product of the force and then the distance, the product of force and distance. And we're told that one of the forces, or to calculate, we have to pick one of the forces, okay, which is 25 Newton times the distance between the forces is 65 centimeters, and this is 25 Newton. So if you calculate, before we do this, we should convert centimeters to the standard unit, which is meters. But we can also do it this way. 25 times 65 will give us 1625 Newton centimeter. All right, so because we have to convert centimeters to meters, we can divide this by 100 and it will give us 16.25 Newton meters. But it is advisable you just convert first before you begin your calculation. And this is where we end the class for the moment of a couple. We're going to discuss very interesting concept in our next class, and the concept is the principles of triangular forces. Previously, we discussed the principles of two forces when two forces are acting on a particular object. But in this case, we are going to discuss what happens when a system of force or system of forces acts on a particular object. I'm sure you would not like to miss the class. So if you have questions, if you have worries, you can drop them on the platform, as we will always be here to attend to your worries. So see you in the next class.